In this example, we're being told that we have this region R here that is created by an area bounded by the graphs of e to the x, e squared, and then just x equals 0. Oftentimes x equals 0 just means it's closing off a point in the region where the graphs don't intersect each other. And then based upon that information, they want us to find the volume that is formed by revolving R about this line y equals -2. What we're looking at here is called a volumes of rotation process. Oftentimes this one is referred to as the washer method because we've got a hole in our graph when we end up rotating this. This is an integral setup, and what that integral setup looks like is this would be the integral from a to b of pi times, and then you're going to have what they call your outer radius squared minus your inner radius squared, dx. And so what we have to do is we kind of need to figure out what our outer radius equation is going to be and what our inner radius equation is going to be. And we'll start off by trying to figure that out by giving ourselves a graph to work from based upon the regions that they told us. Luckily for us, this is a calculator required section, so we can use our calculator to give us a little leg up on what this graph would look like. So I start off and I'm just going to open up my calculator. I'll go to my y equals and I'm just going to graph what they told me. So I'm going to graph e to the x, so e to the x and then e squared, and graph that. And so that first graph is e to the x, and the second graph, the red graph, is e squared. So when I come back through, if I just kind of sketch out my regions now so that I can see what I'm looking at, I've got e to the x coming through doing something like this, and then I have e squared cutting across doing something like this. And so that x equals 0, like I said, that's really what's sort of closing off this region for us. So the region we're looking to find rotated is that region right there. The thing that oftentimes trips people up on this is when we start rotating this around something that's other than the x-axis. So what we're also being told right now is we want to rotate this all around the line y equals -2. So what I do when I'm doing this and trying to figure out my inner and outer radius is I start by drawing from that line that I'm rotating around, and I draw up until I hit the first graph. And whatever graph I run into right there, that's what's creating my inner radius. And then I play the same game and say, okay, well, what am I going to hit second? So after I draw through the first graph, I run into the second graph, and now I'm looking here at my outer radius. It's going to go up to that e squared graph. So if I can figure out an equation for the inner and the outer, those lines that I'm drawing right here and right here, then I can sort of put those into my formula real fast, and I'm pretty much done at that point. How you determine these, this really kind of comes back to the area between two curves setup. So whenever I want to find some gap, some line like this from here to here, that gap is going to come from taking the top equation and subtracting off the bottom equation from it. So when I look at my inner radius formula right now, the equation on top, that's my e to the x graph. So that would be e to the x, and then I'm going to subtract off the bottom equation, which is this y equals -2. So minus a -2. So I'm looking at e to the x plus 2. The outer radius here, I play the same game with. I say, okay, well, my top equation for this line right here, that top equation is e squared. So my top is e squared, and then the bottom is still this y equals -2 down here. So I'm going to do minus a -2. And so out of there, I would end up with e squared plus 2. So now I have formulas for my inner and outer radius, and now I can go ahead and plug those into my integral setup over here. And so I would go integral of pi times, so then I want my outer radius formula first. So e squared plus 2 squared. Then I'm going to subtract off of that my inner radius squared. So then e to the x plus 2 squared dx. When you go to look at your answers, you'll notice that your bounds are all the same. We can see clearly that this region starts here at x equals 0, and then it's going to end over here at x equals 2. So that's where we're getting our 0 to 2 that you see on all of those answers. And then one of the things that they like to do on these is they also like to pull constants to the front. So I can pull that pi out to the front, and then what I'm left with is just this portion. So I'm left with just e squared plus 2 squared minus e to the x plus 2 squared dx. And they don't even want us to find the answer to that. They just usually want us to find the setup. And so if I go and look for my options up above, I can see that my setup looks exactly like option C. So the key on this problem first was identifying this as a washer method, so you have to know this integral formula to get started. And then when we're doing these inner and outer radiuses, it's really important to draw out your picture so that you can then draw these lines here to define what that inner and that outer radius is going to be. And then we use this idea back from the area between two curves of when I need to find that distance, that's always going to be whatever the top equation is minus the bottom equation. That's how you create your two inner and outer formulas. And from there, you just pop them into that integral setup. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.